Here's the apparatus we're going to use to measure the Planck constant. This is the one where we use a photocell, which is here. We're going to vary the frequency of light hitting the photocell with these colour filters here, and we're going to measure the corresponding change in the stopping potential, which we're going to measure with a voltmeter here. Okay, so this is the important piece of kit here. It contains a photocell, which is here. You might recognise the circuit symbol. Internally inside we've got a variable resistor, and we've got a battery. We've got an internal battery. It's one of those rectangular 9-volt batteries, which is inside the box. And we can change this knob here. This just changes the resistance on the variable resistor, and as a consequence we can vary the potential difference across these two terminals here, which is the potential difference across the photocell. Okay, so first thing we're going to set up is the voltmeter. Now, because this has got an internal battery of 9 volts, we're going to have this on the 20 volt range. So if we just connect there like that. So at the moment, yeah, you can see the voltage. That's the voltage across the photocell, and we just literally can change that by increasing or decreasing the resistance of the variable resistor. We want to start on 0, so let's take that right down. That just means now that the slider on this variable resistor is at the bottom, so there's 0 potential difference between this terminal and this terminal. So we're going to start at 0, because remember, to find the stopping potential, you increase the negative potential difference until the current in the circuit drops to exactly 0. Okay. Now, how are we going to measure the current in the circuit? Right. Could use one of these. This is a double banana clip to coaxial that goes in here like that. Now, the ammeter that should normally be used in this practical has to be very, very sensitive. Now, the one that's supplied with this kit is this one, and this is called a pico ammeter, which is a very, very sensitive ammeter. You can see the sort of ranges of currents that you can measure there. You can measure all the way down to picoamps, which, if you remember, is 10 to the minus 12 amps. So that's a pretty serious ammeter. The problem is it's broken. So we're going to make do with a regular multimeter. So we do get a decent results from it. So as long as we have it on the most sensitive setting for current, which we have that, hopefully you can see there, that's all the way down to 20 microamps. Micro being 10 to the minus 6, obviously. So get the ammeter set up as well. Okay, not 10 amps, and always to com. So as we can see there, we're getting a current of 0.43 microamps in the circuit. Now, where that current is coming from, any ideas? Right, it's coming from the visible light, the ambient light, well, it's actually the light from the camera hitting the photocell, liberating electrons, and then electrons passing around the circuit. Okay. Now, obviously, if we shine, okay, this is the same torch you saw last lesson. Okay, or in the last video. So we're going to use a combination of the torch and our set of 8 filters. Okay, so if I shine the torch onto this photocell, we obviously get a much bigger current because we're liberating more electrons, aren't we? With the torch on, a strong torch, more photons, more electrons. More electrons per second, higher value of current. Make sense? Right. So we're ready to go. So you need to write down, okay, as we go through which filter I'm going to use, and then what the stopping potential is. So we'll go with the first one. I'm going to go through in the same order that I gave you in the last video. So we're going to start with red. Okay, so this is filter number 608. 608 is not the wavelength, it's just the filter number. I'm going to give you the colour and the filter number. So red 608. And simply just goes on top of the photocell, and we put our torch on top like that. Easy peasy. Okay, all we need to do now is to turn up the voltage, turn up the negative voltage by tweaking the web resistor until the current just drops to 0. Are you ready? Right, let's take the voltage up. Now, as you can see, it jumped up very, very quickly there, didn't it? Okay, so we need to do that a bit more slowly. Okay, obviously not as good as a pico ammeter, but it's the best we can do. Right, so there's your first stopping potential. We have a stopping potential of 0.10 volts. Okay, back to 0. Right, red filter, done. Next one, I think I called this orange 1, didn't I? Because we've got 2 oranges. Okay, let's call this orange. This is 607. Orange 607. Torch goes on top. Turn the voltage up. As we turn that negative voltage up, the current will drop to 0. Good enough? Right, there we have it. There's stopping potential for the orange one, the first orange one. 0.30 volts. Take the potential back down to 0. Next one. I called this orange 2 in the previous video. This is orange, filter number 808. Okay. Much bigger current here. So I take the voltage up, current's going to drop, current's going to drop. .30. So we're getting the same stopping potential, aren't we? Okay, we'll go with that one. Unsurprisingly, same colour filter. Next one. Yellow-green. This is filter number 605. 605. Take the stopping potential back down to 0. Torch. And go back on. There you go, 0.45 volts, the stopping potential for the yellow-green filter. Filter number 605. Next up, green, filter number 807. Stopping potential back to 0, and then turn it up gradually until that current just drops to 0. .48 volts stopping potential for the green filter. Blue-green, filter number 603, blue-green. Stopping potential to 0, torch goes on, stopping potential or potential difference, we turn up, we turn up, we turn up, we turn up, we turn up until we reach that magic stopping potential where even the fastest electrons are just stopped short of the cathode in the photocell. So there you go. There's your stopping potential for this filter, 0.58 volts. Okay, back to 0. Deep blue, filter number 806. Torch on. Okay, 0.81, we happy with that? Yep. There we have stopping potential for the deep blue filter, 0.81. And last but not least, the violet, back to 0. And then turn it up until that current just drops to 0. .86. Okay, so stopping potential for the final filter, the violet filter, 0.86 volts. Okay, so that was for the violet filter, which was filter number 600. There we have it. Right, you now have, you should have a range of wavelengths that corresponds to the first video of all the filters. Now you need to convert those wavelengths into frequency, and we've got a range of stopping potentials. So it's just simply a case of plotting stopping potential against frequency, and from the gradient we can find the Planck constant. Okay, thank you very much. See you in the next video. Bye.